So first question, it's a clock face. So you know what? For me, drawing comes in handy. These circle problems. So here's a clock face, and one of the dials, right, goes all the way to the edge. So they're asking, and obviously from the center to the edge, let's call the radius. Let's label it R. Figure out the length of the dial, blah, blah. Okay, so, and we know that the area, so the area inside, right, the space inside in square units is 530.66 inches squared. Right, so they're giving me the area. I have to find the radius, obviously. The only formula I can use is this. 530.66 equals pi r squared. I'm going to divide both sides by pi. Right, so when you divide both sides by pi, let me see, 530.66 divided by pi, and I get, and again, you're going to leave that in your calculator, 168.9143.242. We're going to take the square root of both sides, that goes away, take the square root of this, and r equals, remember I said r equals, so if I take the square root of that, how do I do this? And I get 12.996, which we're going to round this, to 13. Round it to the nearest hundredth, so the radius is 13. So, but remember, it's plus or minus 13, okay? And obviously, we want the plus 1, okay, because it's distance. 2, again, another same type of question, exactly the same. So the area of this circle, let's see if I can draw a better circle. Sort of, is 314 square centimeters. We want the radius, so A equals 314 centimeters squared, and we're missing the radius. So exactly the same thing. A equals pi r squared, so I might even skip some of these questions. 314 equals pi r squared, so we're going to divide both sides by pi and take the square root of both sides. So the pi goes away. Now, 314 divided by pi equals 99 point, and I'm going to leave that number in my calculator, 99.9436. That's what you're looking at your calculator, r squared. How do we get rid of the exponent here? We take the square root of that side, take the square root of the side, there's a 2 here, invisible, we get rid of that. R equals, and if you press square root, right, and then move the cursor up, press enter, you'll see that it transfers to under the radical, and press enter again, you get 9.997. I don't want to say it's 10. Well, I guess it rounds off to 10. I guess for our all intents and purposes, it rounds up to 10 plus or minus 10. Again, I said right, plus or minus 10. We're taking 10 is the radius, 10 centimeters, right? All right, so again, A equals pi r squared is just not only to find the area of a circle, right? But we can also find the radius given the area, right? So it goes back and forth. 3, again, same type question. Sorry, I should have taken a look at these questions. We want the radius and we want the diameter. So we're missing R and we're missing D. Okay, and the area, the whole thing. So the space inside is 200.96 meters squared. You're missing the squared over here. A equals pi r squared. And again, 200.96 equals pi r squared. We're going to divide this side by pi and this side by pi. 200.96 divided by pi equals 63.96755.473 r squared. Remember taking the square root of both sides, and we get that. Hang on a second. Square root of both sides. Enter. Enter again. 7.99. So r equals plus or minus 7.99797, which we're going to round to 8. So it's plus or minus 8, and obviously we want to use the positive 8. Find the area of the shaded region. All right, so we have, think of a donut, or you have the original source. So yeah, I guess it's easier. So if you take, there's 2 circles in here, Right? We don't know what the shaded region is. Give me a second. Oh, I don't know what the shaded region. Let me get the original copy. Found it. So I might have to do this for this one. So let me draw a circle. I draw it about the same size. Right, that's about the same size. So now if you think about this, that's the circle. Oh, okay. So let's draw the radius, and the shaded area that we're looking for is this, right, according to what I have. Right, so here's a shaded area, the yellow area, right? This whole thing is yellow. Right, so let's think about that. The whole thing is yellow. Somebody comes in and punches a hole through it. What's left over? So that's what the question is saying. Now, let's look at the radius of this entire circle. The radius of the entire circle is the 9, right? Plus the 3. So the radius here is 12. Okay? And then we have a circle inside of circle. Let me get the other circle. Draw a smaller circle. Right, and we have this circle that it's in. Oops, yikes. We have this circle, right? Who's inside this circle? So now, I can put it inside. And the radius of this, and I'll change colors. Right, the radius of this is 9. Hopefully that makes more sense to you now. So the radius of the big circle is 12, and this radius of the small circle is 9. I'm gonna take this guy apart and put it over here. I'm going to make this the 9. So hopefully you understand what is going on. So you can always review, rewind. So we have a big circle and this circle that's inside that circle, right? So I want to, let me see if I can change colors. Property browser, is that what it's called? Yeah. And let me change the color to white. All right, so again, I'm going to punch a hole. So if you punch a hole through the big circle, that shaded area is what you have left over. So in order to do that, it's the area of the orange circle. Let's see if I can, of the orange circle, minus the area, and make it a small one, minus the area of the, I know you can't see white, but minus the area of the smaller circle. So that's what we're doing. So let's find the area of the big circle. The area of the big circle is A equals pi r squared. Area equals pi times, and r is 12 to the second power. 12 to the second power is 144. We're going to leave this in terms of pi. So this is going to be 144 pi, whatever that is, inches squared. The area of the small circle. The area of the small circle is A equals pi r squared. A equals pi, and the radius here is 9 to the second power. 9 to the second power is 81, or we're going to leave it in terms of pi. We're going to write 81 pi inches squared. Now that I have both measurements, all I have to do is subtract. So the big circle measures, the area is 144 pi. The small one is 81 pi, and we can subtract. So 144 minus 81, 144 pi. You can multiply and then subtract. I'm just going to do 144 minus 81. 144 minus 81 is 63. And we're still going to leave it in terms of pi inches squared. So this area that's left over here, right? This area that's left over, the shaded area, is 63 pi inches squared. Second question, I know you can't see it over here, but the shaded area, so here's a circle, and the shaded area again is this, right? That's the shaded area, right? So you have a circle, and I'm going to use the one that I already drew, and again, we are going to, I guess the hole is a little smaller. We're going to take that, make a hole in the middle, looks like a bagel now, and how much is left over. So This one is more clear, right? Because they say that the radius, I'm going to separate the two circles. The radius of the bigger circle is 7. The radius of the smaller circle is 2 inches, 2 feet, sorry. So again, area of the big circle. So area of the big circle, on the right of big is a equals pi r squared. A equals pi, 7 to the second power. 7 to the second power is 49, and I'm going to multiply that by pi. I got 49 pi feet squared. I'll leave it in terms of pi. You can multiply if you, those of you who want to multiply 49 times pi and get whatever number, you're more than welcome to do it. Okay. And then a small circle here. Area of the small circle. Small circle. Again, a equals pi r squared. A equals pi, and the radius of the small circle we can see is 2 feet, or 2 to the second power, which is going to be 4. So a equals 4 pi feet squared. Now you got two choices. Some of you can do 49 pi minus 4 pi, and we can get our answer really fast. That gives us 45 pi feet squared. We'll leave the answer like that. Those of you who want to multiply, and I'll do that, 49 times pi, enter. So those of you who multiply, depending on what the question says, if you can change this to 153.94 rounded, nearest 100, minus 4 times pi, it's going to be 12.57 rounded. And if you subtract those two, so you get 153.94 minus 12.57, you're going to get 141.37 feet squared. Okay, so you got these two acceptable answers, and just out of curiosity, let's multiply 45 times pi just to get a numerical value. And if you multiply 45 times pi, if you multiply these two, you'll see that in your calculator you get 141.37 rounded. Sometimes there might be a little bit difference because of the rounding, okay, but that's okay. Last question, the same thing. You have a circle. Oh, look at that. And you have another one inside. This one is actually a little bit bigger. Right? I'm just trying to make it. So there you go. So they tell you that this guy here is 4. Right? That is 4. Let me just try to make it a little bit prettier. So this right here is 4. Right? And then they say that this from here to here is 12. So let's take this. So now, let me just write this a little bit better. This is 4. Now the question is, how much is this guy? So if you think about it, let me take this circle out. If I take the circle out, I have the radius of the big circle. So area of the big circle, I can do, because you can tell, look, it's 12, right? So a equals pi r squared, a equals pi, and the radius is 12, or 12 to the second power. And we're going to get area equals 144, because 12 to the second power is 144, pi, whatever, yards squared. Now, the small circle, let me put this back in here. Do we have the radius of the small circle? No, we don't. Right, so the small circle, if you focus just on the small circle, this one, do we have that radius? No, but notice that that radius would be the difference between 12 and 4. So if you took 12 and subtracted, so if I, from this 12 over here, right, so let me take that 4 over here, and this is 4. Right, same thing. So if the whole thing is 12 and you subtract 4, what's this left over here? This leftover would be 8. And that's the radius of your small circle. So in your small circle, area, all right, small, a equals pi r squared, area equals pi times, and we said that it's 8, right? So it's 8 squared, which is 64, and we're going to write 64 pi yards to the second power. Now, again, we're not done because we got to subtract those two, and 144 minus 64 is 80. So 144 pi minus 64 pi equals 80 pi. You can treat pi as if it was a variable. So that'd be no different than doing 144x minus 64x, right? You can treat it that way. 80 pi. So the answer is 80 pi yards squared. If you leave it in terms of pi, if you want to go crazy, you can multiply 80 times pi and get whatever numerical value, 200 and something. Okay, so again, it's just not, I mean, you're not just going to get, here's a circle, here's the radius of 5, what's the area, right? I mean, there should be more to it in the problems that we do. Okay. The last 4 here, or these 4, is about, we're going to talk about find the radius, right? So I think, did we do that in the top? Yeah, so it's, again, same thing we did in the first 4 questions. So we don't. Area equals, so if you have a circle and you know that the area, the whole space inside is this much, what's the radius, right? So again, a equals pi r squared, 803.84 equals pi r squared, and divide both sides by pi. This goes away and we're gonna left with r squared, and let's see, 803.34 divided by pi, it's going to give us 255, and again, I'm writing what you see in your calculator, 255.711064. Take the square root, and r is going to give you plus or minus, give me a second, 803.84 divided by pi, 803.84 divided by pi, enter, and we're going to take the square root of that, enter, we're going to get plus or minus 15.99 or 16. Remember, it's plus or minus, but we take the plus. Second question, same exact thing, equals pi r squared. We have a circle whose area is this much, and we want to find the radius, and that's what's missing. The area is 1017.36 equals pi r squared. Divide both sides by pi, and in your calculator right now you should be looking at 1017.36 divided by pi equals, you should be looking at your calculator at 323.8357458. Square root of that, and r equals plus or minus, enter, 17.99, and we're just going to write 18 for our purposes. 1,256 is the area, right? Square feet, or feet squared. We want the radius, again, equals pi r squared, 1256 pi r squared, divide both sides by pi, right? We want to isolate our r. So now our radius r is all by itself, but still has an exponent of 2. 1256 divided by pi, enter. Take the square root. You're going to get like 20, right? Round it. Enter, yeah. We get 19.9914, 19.9949. So just, again, I'll write it. 19.99492978. Square root, that 2 goes out with this invisible 2, and r equals 20. This question, again, repetitive, I know. I apologize, I should have cut at least 2 of those. A equals pi r squared, 1384.74 equals pi r squared. We're going to divide both sides by pi, that goes away. Let's divide that by pi, 1384.75 there, divided by pi. Enter, we get 440.776418 equals r squared, square root again. Here's that invisible 2, takes care of the exponent. And r equals plus or minus, enter, plus or minus 20.99, and we're going to take the 20. Alright, so that was that. I think that was the easier. Well, not easier. Now we get to do this one. Alright, so We selected a few. Hopefully not too many. Okay. So I believe number 2. So a metal worker cuts a large semicircle with a diameter of 28. Right. So we have a picture. So the diameter from P to Q is 28. Then cuts a smaller. So he takes this smaller circle out. Right. So imagine a pizza and somebody takes a bite, and this is the bite that they took. What's left over? I think is that what they're asking? No, they're not. I apologize. We're not talking about area. So they're asking if the diameter, blah, blah, find the distance around the shape. So if you were to take your dog or cat for a walk and you walked this shape, I think we did this problem, made a left, right, you come over here, made a right, and then you do this middle half circle. How much did you walk? Well, first of all, first part that you walked is this. Let's talk about this. That's a semicircle, or half the circumference of a circle, right? So this stretch right here. So that's half the circumference of a circle. I'm just gonna write it down, right? So the distance you're walking would be half the circumference of a circle plus 14, right? Because then you're gonna walk this little stretch, and then plus half the circumference of the smaller circle, half the circumference of the smaller circle, right? I forgot to write it. Half the circumference of the big circle. So that's what you have to do. All right, let's focus on the big circle. On the big circle, remember how do we find diameter? Sorry, how do you find circumference? Half the circumference is c equals pi d, right? So c equals pi times diameter. Circumference equals pi. What's the diameter of the big circle? So focus on the big circle. Sorry, I can't trace it properly. Focus on this, right? So imagine it was a big circle. What would be the diameter? Diameter is this line over here, and diameter would be 28. So 28 pi, and I'm going to multiply that. I actually want the numerical value. 28 times pi, enter, I get 87. So the circumference is 87.96. But guess what? I didn't walk the full circle, right? I walked half of it. So I'm going to take that, and I divide that by 2. And my answer, rounded, so I'm going to take that, divide that by 2. So the part that we want is 43.98. So this stretch right here, I'm going to write 43.98. We have the 14, which is this guy right here. So we just need the half circumference of the small circle. So now the small circle, let me go here, c equals pi d. So let's go focus on the small circle, pi, and then let's look at this guy here. What's the diameter here? Diameter is 14. Let's get a numerical value. 14 times pi. Enter. Switch that. It's 43.98229715, which I'm going. Let me write that all down. 229715. I'm going to take that and divide by 2 because I'm not really walking the whole. I'm not walking this whole little circle, right? I'm only walking half of that circle. So I'm only walking this stretch right here. So I only want half the circumference. So if I divide that by 2, I'm going to get, divide that by 2, that it is 21.99 rounded. So if you want to find out how much you walked, and then let me put 21.99 over that stretch, you add all three numbers. So we get 43.98 plus 21.99 plus 14. 43.98 plus 21.99 plus 14. Enter. Final answer, 79.97 centimeters. All right, moving along. Then I have to do 3 again. So all the problems are the same idea, right? So think about what you're walking. So here, again, you're walking your dog. This, let me pick a different color. Let's start with this. That stretch right here is a quarter of a full circle, right? So it's a circumference divided by 4. You're not walking the full circle, you're walking a quarter of it, right? So let's think about that circle. Let me try to draw that circle. So that circle would look like this, right? The big part, and the part that you're walking is this stretch right here, right? So first, let's find out what the distance around the whole circle is. Well, they tell you that from here, and look at this right here, 60. So from there to here, 60, which means that other side would be 60. So the diameter, the radius is 60, but the diameter would be 120. Like I said, I like to just use c equals pi d. So c, circumference of that circle, is pi times the diameter, right, which is 120. If I want a numerical value, you're going to go 120 times pi, enter. You're going to get this number in your calculator right now, 37699111184, which we're going to divide that by 4 because right, I'm only interested in that stretch. So if you divide that by 4, you get 94. So the part that we want is 94.25 rounded. So this stretch right here, I'm going to write 94.25 rounded. So from here to here is 94.25. Okay. Allow me to erase this. And again, you're taking your dog, you walk that quarter of circumference of that circle. Now you're going to walk, let me change, see if I can change colors. You're going to walk this part right here. Oh, come on. Walk this part. Now notice that that's half of the circumference of that circle. Right, so let's focus on that circle. So let me see if I can draw it. So if a smaller circle, right? See if I can draw that. Right, so I'm focusing on that, and they have a line like this. Now, and that is 60. Right, so that is 60. And so imagine if I drew a circle over here like that, right? This part is the same thing as this part, which is 60. So I'll take that. So circumference again, if I were to walk around this whole circle, would be pi times d, or c equals pi times 60. 60 times pi, enter, equals 188 point. So again, the full lap would be 188.49555592. I'm not interested in the full circle. I'm only interested into what? I'm only interested in half, which is half of that. So I'm going to divide that by 2. And I get, in my calculator, that this stretch over here is 94 point, again, 25 rounded. Interesting. Look at your numbers. Right, 94.25. And then finally, well, this one we don't have to do any calculations. This is 60. Right here. So total answer, 94.25 plus 94.25 plus 60. And that's our final answer. 94.25 times 2, enter, plus 60. And I get 248.50 inches. And that would be the distance around that particular shape. Again, a little bit of work, but nothing crazy. I have this question. 2 more questions. Alright, as part of her artwork, Sally begins, blah, 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 blah. The shape is made of a semicircle and a quadrant. Find the length of the wire. Okay, so again, I like the dog. I take my dog for a walk, and I walk this, and I walk this, and I want to walk this. And then I'm going to walk this. Oops. Alright, so there's 4 parts. 1, 2, I'll put 3, 4. First part I know is 12, so I'm going to write that 12. Second part, right here, I'll call this, the second part is a quarter of a circle. The third part, I'm going to write a quarter of a circle, right? Plus the third part is easy, it's 12 again. And the last part is half of the circumference of a circle. I'm not going to write half of a circumference of a circle. So we're missing these 2 parts that I underlined. Quarter of that circle and half of that other circle. So let's focus on, well, let's see if I can draw this. Here is that quarter circle, right? And they're telling me that this is 12 right here, which is the radius, right? So imagine, so let me complete that circle if that was a complete circle. Right, so again, I'm focusing here, right, which is this part right here. Right, so make that a little darker, so that's the part I'm focusing on. They're telling me this is 12, right, which is the radius, which means this other side is also 12. That means the diameter, so the radius is 12, and the diameter is 24. So C equals pi d. C equals pi times the diameter, which is 24. Let's give us a number. 24 pi times pi. Enter. We're going to get this number here, 75.40. Well, actually, let me not round again. So I'm going to round the final. 75. So in my calculator, your calculator as well, you're going to get 75.29822.369, and we're going to divide that by 4 because I only want one of them, right? And then divide that by 4. So the part that I want, which is the shaded area, is 18.85 centimeters. Okay, so over here, I'm going to come up top and place the quarter, and I'm going to write 18.85. I know what the quarter is. Now I need, well, I need this part here. I need this part here. That's what I'm looking at, right? So I found, so that's 12, and let me finish this. It's 1885, right? This is 12, so I know that's 12, so I need this. This is my last part. All right, so again, let me draw that, sort of, and then let me write the measurements. So this is 12, according to the picture. If that's 12, guess what? This is also 12. And then let's complete the circle. So if that's 12 and that's 12, right, it means that the diameter, right, the whole thing, radius is 12, radius is 12, radius is, r is 12. That means the diameter, right, the whole thing is 24. So C equals pi d. C equals pi times the diameter, which is 24. So let's do 24 times pi. Enter. And then, remember, I'm only interested in the bottom half, right? I don't want the full circumference. So the full circumference, we already know it's 75.39822.369, right? And this time around, I'm going to divide that by 2. So because I don't want the full circle, I want a semicircle. If I divide that by 2, I'm going to get 37.70 round. So this stretch right here is 37.70 round. So now I can come back here, half of the circumference of a circle, and I'm going to write 37.70. Do I have all the parts necessary now to, figure out the distance around this shape? Yeah, I do. So 12 plus 12 plus 18.85 plus 37.7 equals 80.55 centimeters. Again, a little bit of work, but who's afraid of a little bit of hard work? 8, I think. Yeah, 8. What is this? An athlete around the... okay, so find the length of the running track first, and then we'll deal with speed. So if you run around this track, what is the distance that you run? Okay. Well, we know this part here is 100, right? Which means this part here is 100. So when you run, you're gonna run 100 meters. You're gonna do a half a circle here, half the circumference of that circle, plus 100, and plus half the circumference of another circle. Well, you know that this half and this half becomes one full circle, right? The diameter, this part here is 64. So literally you're running, so you need 100 plus 100, which covers this part and this part. Now you need to cover this guy and this guy. Well, that guy and this guy and that guy is actually a full circle. The diameter is 64. God, my drawings are awful. Diameter 64, so C equals pi d equals C pi times 64. Let's multiply those two. 64 times pi, enter. Your actual value is 201.06. So, and if you want to take this and divide it by 2, right, it means that this side over here is 100. Right, this distance right here, again rounded, 100.53. And this guy over here, this side, right, that you're running, is 100.53 meters, right, this semi. So now you have all four parts, 100 plus 100 plus, again, you can use 100.53 or 201.06. It's up to you. So, plus 201.6 equals 401.6 meters. So the distance around this track is 401.6 meters. Okay. Second question is, an athlete ran around the track one time at an average speed of 8 meters per second. How many seconds did it take him to run around the clock? So, you can set up a proportion here if you like. If you think about it, so here's the rate he runs at 8 meters per 1 second. The question is, if he's going to run 401.6 meters, how many seconds will it take? All right. Cross multiply, we can do 8x. 1 times 401.6 is 401.6 divided by 8, divided by 8. X equals 401.6 divided by 8 equals 5.02 seconds. No, wait a second, sorry. 401.6 divided by 8. What am I doing? 50.02 seconds. Alright, that's how long it would take him to run the whole track. Okay, that was it.